I am DJ Hasler with Xantrex, and today Larry Rambeaux with Purkeys, will be presenting on how to get your fleet ready for winter. Winter is just around the corner. It's a time of year when electrical systems must be at their peak performance. When the weather is warm, cranking amps are much lower, battery requirements are low, and the electrical system is more or less taking it easy. As the weather turns to get colder and we get close to winter and into winter, the cranking amp requirements can sometimes triple. There's increased stress on the starter, increased stress on the batteries, and voltage drop in cables will also increase. Why do electrical problems show up on the first cold day? And now I will turn it over to the real guru, Mr. Larry Rambeaux.
All righty. When we talk about cold weather, it's, a lot changes, and a lot of times people will say that, we had our first cold snap and my battery failed. No, your battery didn't fail just because it got cold. That battery has been losing capacity, and finally when you really ask it to do a strenuous job such as cranking a cold engine, suddenly those batteries can't perform anymore. But if you look at the chart on the screen right now, it kind of shows a comparison of temperature of a battery versus an engine. When it's a nice warm day, basically you've got a big battery. That battery can give, take energy in and give energy off very easily. And that battery is very efficient. So there's lots of capacity there. If you look at a typical truck that may have 4 batteries, on a nice warm day or when that engine's warm, it'll probably crank off 1 battery. And if you look at the engine at this same time, in essence, it's small because it, again, cranks very easy. But as that temperature goes lower and lower, basically your battery becomes less and less efficient. It gets smaller in essence. But as that engine gets colder, it becomes a bigger engine because it's so much harder to crank. One of your biggest factors on engine crankability is oil viscosity. And when we talk about this presentation today, we're not just talking about trucks or just reefers or just liftgates or inverters, all these things that are on trucks, is these are all very important. And one of the things for any type of an engine, oil viscosity is your biggest factor. That is, that engine oil or hydraulic fluid or whatever it's having to turn gets thicker, it becomes that much harder to crank. So if you look, that yes, that battery gets much smaller, so you may need 4 batteries, because look how much bigger that engine gets. We're going to start off with our first poll question today, is what equipment can benefit from a good winter PM? And to answer these, just go on the little circle and click on them and then hit submit. But, first option is trucks, second one is reefers, third one is liftgates, or the fourth option is all the above. So I'll give you a second there to click your answer and hit submit. I'll give you a few seconds for everybody before I advance to the next slide. But again, what equipment can benefit from a good winter PM? Hopefully everybody's hit submit. I'm going to go to the next slide. Everybody got it right. All the above, yes, they all have different functions, but they still all are electrical, systems that all depend on the system working properly. We're talk about first thing is, the impact on batteries and what all happens. And, how are the batteries impacted? One of the biggest things, batteries' job to do is to crank an engine. We got 4 batteries like we'd find in a typical, Class A truck connected to a starter. When it's a nice warm day, and again, those cranking requirements are much lower, starter pulls will say 650 amps. So each battery only has to supply 162.5 amps. Now, is it all going to be, perfectly even? No, this battery's going to give a little bit more than that battery or whatever. But at the end of the day, each battery, doesn't have to give a whole lot of energy for it to crank. So you could have, very old batteries, discharge batteries, worn out batteries, whatever. On a nice warm day, it'll crank fine. But watch what happens when it gets colder. Is instead of 650 amps, we jump up to 1,700 amps coming from the batteries. Now look what each battery has to be able to give off. And we're assuming that these are all done when, you know, batteries are good state of charge and, you know, recent or a decent age. As batteries age and the state of charge goes down, they're going to have a harder and harder time giving off this energy. As we said before, that how is the starter impacted? The load can more than triple in cold weather. Seen it as much as 4 times the load. That starter has no conscience, that its job is to crank that engine. It doesn't know that, you know, it's got very thick oil in it, you know, condition of the engine, whatever, but it makes it much harder, and that starter that, again, worked fine for months, suddenly fails on you. Did it actually fail now? No, it's actually been probably a bad starter, but we just asked it to do it a very tough job now. We talk about voltage drop, that the higher the current, the more voltage drop we're going to have. Because one thing about, you know, cable resistance, it doesn't change. But as the cranking amps goes up, that voltage drop's going to go up as well. And when voltage goes down, amperage must go up. And that's going to impact every electrical device on that, again, whether it's a truck or a reefer or a liftgate, whatever, those are all very detrimental to the life of any electrical component. That voltage drop, the more voltage drop you have, the less voltage you have available at the starter, and the less voltage at the starter greatly or directly impacts cranking speed. Basically, every volt you lose between the batteries and the starter, you lose 30 RPM cranking speed. So again, nice warm day, that engine sounds great when it's cranking. Suddenly you get it cold and it's like, ooh, that thing, you know, didn't sound like it's going to start. That's what happens, is the less voltage was making it to that starter. When we talk about voltage drop, and again, we're talking right now of a, you know, again, like a Class 8 type truck, 4 batteries, heavy duty starter, like a, you know, 40 MT, 42 MT, 39, 44, any of the heavy duty starters. There is a TMC spec for this that says you are allowed no more than half a volt drop at 500 amps. So, again, we're going to talk about a nice warm day, starter pulls 600 amps. A truck that's even right at spec is you drop down to 11.1 volts at the batteries, you're all the way down to only 10.5 at the starter. And this truck is in spec, that it meets that requirement. If you look at the exact same scenario, we're going to say it's 3 times the current. So we're pulling 1800 amps. The voltage drop's still going to be the same because you're still going to have the same resistance of those cables. But since you're pulling 3 times as much current, you're going to have 3 times as much voltage drop. So we had 10.4 at the batteries. Obviously, the batteries are going to drop lower because of more current. But now look at the voltage you have available at the starter. That is a huge impact on the crankability of that engine. And it's the type of thing that, you know, may not cause that starter to fail today, but it is going to impact its life, you know, every time it's cranked in those type of conditions. And again, it doesn't matter if we're talking about, you know, lift gates, we're talking about reefers, we're talking about trucks. The biggest issue with, you know, all equipment is, you know, getting the batteries charged and keeping them charged in these conditions. One thing is about batteries. In warm weather, batteries are like a glass of water. It's very easy to fill that glass, and you can just dump it out very easily. Cold weather, batteries are kind of like me. They don't like to work. Batteries become like a tube of toothpaste. It's hard to get anything out of them and almost impossible to put back. Look, here's some charts, a little bit of an eye chart for you, but it does show the battery's ability to take a charge, but the colder it is, the less efficient they are. That you get a very, you know, cold soaked battery, they just will not take a charge. That's where fleets run into a lot of issues, is they have a truck that doesn't start, they go out and, you know, jump start it and send them on his merry way. What do you have the first time to shut that truck off? You have a no start because those batteries wouldn't take a charge. And even though he drove for several hours, he technically still has dead batteries in that vehicle. That's where the alternator becomes very important. You got to make sure the charging system is up to spec on it. That you have to have the right cabling. That one thing is you can spend all the money in the world, and you can do everything you want to and buy the best batteries. If you don't have cabling that connects them properly between the starter and the alternator, the system's not going to work. All you're going to do is keep changing batteries. Yeah. Systems are, critically important. Is when that engine is running, we need to make sure we get all the energy back in those batteries we can. Obviously, winter becomes a much more difficult task. Again, harder on the system. The batteries don't want to take a charge. Maybe we don't run as much as we normally would. So many impacts or things impact those batteries' ability to get a charge. The other thing is you look at, vehicles independently and different issues, with each one. It's no secret there's idle restrictions. Not just because of where you are, they don't want the noise, don't want the pollution. We're encouraged to reduce idle time to save fuel. Wintertime, we see higher loads for drivers, whether it's because of, electric blankets or heaters. May spend more time in the cab, so they may cook more meals, but many things, and not to mention, we're going to say it many times, just the cold temperatures, how they impact the crankability of that engine. Liftgates, one of the things we really see in liftgates is not so much they pull any more current in cold weather because of the thicker hydraulic fluid, but it takes longer to do a cycle. So still, no matter what, you're pulling more energy out of those batteries each time. Those batteries are less able to take that charge when the vehicle is running to get charge time. The other thing, too, is with the thicker hydraulic fluid, a lot of fleets go from a gravity down to a power down just to get the gate, to cycle up and down faster. Again, those things are all go back to colder temperatures. Reefers, a lot less runtime in winter. That if you're hauling a load of produce, the reefer doesn't have to run nearly as much to keep it cold compared to being in a very warm time of the year. More and more devices are connected to reefers, whether it's for temperature tracking or just GPS tracking. More loads, more energy is coming out, less energy is being able to put back in. So now we've highlighted those issues. We talk about battery starters and alternators. What can you do to make sure you're ready for winter? And oversimplified, but it's really only a 3-step process. And doesn't matter if we're talking about liftgates, reefers, trucks. The first thing we always have to do is check the batteries. The batteries are the hard electrical system. If they aren't right, nothing's going to be right. So we have to test the batteries. And then there is a lot of new equipment now that allow you to test a battery bank. Going into winter, I still really believe in the old school technology that we really need to take everything apart, clean it, tighten it, make sure we do a thorough inspection and testing of everything. Before you load test a battery, it has to be minimum state of charge, 12.4 volts. Same idea. You can't find a hole in the tire if the tire has no air in it. So we have to make sure the battery's a minimum state of charge to be able to test it. You either put your meter across there, depending upon what kind of piece of equipment you use for battery testing. You can look very easily and see if the battery's high enough state of charge. There is a lot of equipment that may still be able to test the battery per se, but even if you're able to test it and says, yes, it's a good battery, you're going to have to do something to make sure those batteries are charged afterwards. So safest thing is make sure they're high enough before you even start. You got to take all the cables off. We don't want any of the cables that impact those tests. That one of the biggest things we always got to keep in mind is the electrical connection on a battery is that lead pad, or some of the premium AGM batteries may use brass here, but that pad is the electrical connection. The stainless steel stud is only there as a mechanical connection to hold that cable down. So we have to make sure it's clean. There's many different types of brushes you can use that will clean that pad good, whether it's like a toothbrush, if you will, that has metal bristles on it, or you use one that goes in the drill. Something to make sure you get a good clean contact area. You have to use lead adapters. Again, when we talk about some of the premium batteries with the brass pads, they do recommend using brass adapters, but you have to use something to get down that lead pad. Use a good battery to test it. Make sure you understand how to use the piece of equipment your shop has for load testing batteries. And again, there's many different types of testers out there. There's some that are only an electronic test, some that are a combination electronic and load test. But if you don't know how to use it properly, testing it does no good. One of the biggest things I will say is you cannot buy a $99 load tester from the discount tool store, because it is not going to do a fair test on the battery. The only thing it's ever going to find is batteries that are just junk. And those ones that are in between junk and good are going to cause you road calls, because you cannot actually tell the true health of that battery. Keep good batteries and replace defective ones. And that's an oversimplification of this, that you have to go back to your fleet's needs and what your policies and processes are. No matter what, we'll all agree that a bad battery has to come out. Different rules of thumb and thought process, you mix and match batteries. Some fleets say if one battery comes out, they all need to come out. The ones that were tested and were good, they can go through a recharge program and be inspected and then maybe reused by matching them up as a group of batteries. One thing about batteries is, we try to discourage having batteries very far apart, whether in specs. Our rule of thumb is keep batteries within 50 CCAs and also keep batteries within 6 months of each other. If not, you wind up with a very mixed match of batteries, and every time you turn around, you're back in that battery box. So again, go to what your company's policies and procedures are, but no matter what, defective batteries have to come out. And the other thing too is, while you're looking at these batteries, don't forget a visual inspection. If the battery's been damaged, who cares how good it tests? It's going to fail on you. And that's not only case. I was working on a truck the other day that one of the cases was damaged, leaking acid. Nobody noticed it. I've seen other ones where people use a lot of impact tools and have damaged the stud and the lead pad. So, look at those things and make sure you get any of those batteries out of the system. Next thing we want to do is check the charging and cranking system. I've actually got a typo here that says charging system. We want to do the cranking system cables first. And why we want to do the cranking cables first is pretty much everybody uses big cables from the batteries to the starter. Then they use the starter as a junction point. So we're going to go from the starter over to the alternator. So we want to test those main cables first. So if you look in the diagram here, again, use an electronic type tester, connect the large leads to the starter, small leads to the battery. And whether you're using a carbon pilot or using an electronic tester, you're going to dial in that 500 amp load. It's going to load it down, or you're going to load it down if it's an old mechanical type or manual type tester. Load it down to the 500 amps. You're going to look at the voltage across the starter and look at the voltage across the batteries. You're allowed no more than half a volt at that 500 amp load. And we're talking again right now, Class 8 type trucks, big cubic inch engines. If you're testing a reefer or testing a liftgate, they all have their same specs, and you'll find a lot of the specs in the information that has been provided. Once you've checked that, you're either going to have to repair those circuits. And that, when we say repair, that may be as simple as taking things apart and cleaning them. One of the biggest things for any type of preventive maintenance, in my opinion, is 3 words: bright and tight. Is if everything is not clean and you get down to a good clean connection, nothing's going to work good. And that will fix most of the issues you will find with this, is just simply a lack of taking things apart and make sure they are clean and tight. So once our cranking circuit is tested, we can move on to the charging circuit. I'm going to show you a little bit more of that circuit we were talking about before. Before we were here just on the starter. Had our large leads to the starter and small leads to the battery. Now we're going to move those large leads to the alternator and test the cables. And we're going to be checking that entire circuit. If our big cables were bad and we didn't address them, our charging circuit could fail and we wouldn't realize it. So whenever we do a charging circuit test, same test again. If we're talking a reefer or a tractor engine, same connections apply, and we're going to use the same spec of whatever the alternator's rated is what those cables have to handle. Got another poll question for you. Is what is the spec for TMC RP129 for cranking cables? We've got 3 different options for you. First one is half a volt while cranking. Second one is 0.25 volts per cable at 500 amps. Third one is half a volt total at 500 amps. And the fourth option is 1 volt at 500 amps. Again, this is TMC RP129 spec for the cranking cables. Give you a couple seconds here to read. Make sure you got it. Everybody submit. I'm going to go on and see what our results are. All righty. Looks like most everybody, or 86.7, got the right answer. We'll go through just a little bit until you know why that is the right answer. The first answer of half a volt while cranking, the reason we can't use while cranking is it depends on the condition, temperature, so many variables. We have no idea what that engine is going to be pulling or that starter is going to be pulling for it to be a fair test. So we have to use a fixed load or an electronic tester to simulate that load. Second one is half a volt. Technically you're right, but technically you're wrong. It doesn't matter as long as the overall circuit resistance is within that half a volt. In a perfect world, yes, we would have equal voltage drop on both sides. That is not always the case. Generally, you'll have more voltage drop on the positive side because you will pick up some extra ground cables or whatever. But honestly, it does not matter as long as you're underneath that half a volt. So yes, C is the right answer. So that concludes all the tests that we can do. Again, battery test, cranking cable test, charging cable tests. But what else can I do to help make sure I'm going to have a trouble-free winter? There's lots of things. And some of this is, you know, you can't fix previous mistakes, but it may be a good time for you to go back and look at your specs for equipment. And again, this could be a webinar all on its own going over all these, but you got three, big components on any vehicle. You either got, well, they all have batteries, obviously. They all either have a cranking motor or a pump motor when we talk about a liftgate, and they all have some sort of a charging system. But you can look at each one of them individually. Am I buying the right batteries? And that can be, a decision between flooded cell versus newer style AGM. Are you using the right CCA for your batteries? Are you using the right reserve capacity? Those have a lot of impact on how well that battery is going to live in your fleet's environment. There's still a lot of misconception that the bigger CCA, the better the battery. No, depends on application. And again, with the number of people we have on the webinar, we could spend hours answering everybody's different questions based on what equipment they run, where they run, how they run. But you do have to look at both of them. You want to make sure you have enough CCAs to meet those cranking requirements, but more importantly, you want to look at reserve capacity and how well can that battery handle cycling. And say cycling, that is being discharged and recharged. All those things add up to how many cycles you're going to get out of a battery, which equates to how long it's going to live. Another thing too is you want to look at warranty on all those. Obviously, the best warranty the best warranty there is the one you never use. So you want to make sure you're using the right battery to make sure you're going to live as long as they need to for what your requirements are. The next thing is, are you speccing the right starter? Still using straight drive on a gear reduction? Is it the right kilowatt rating? Again, if you do a lot of, cold weather, you may have to, upgrade to a higher kilowatt rating starter you normally would. Take advantage of the IMS switch. When we say IMS, that's integrated mag switch. Not everybody's done it, but a lot of them have now, or it incorporates the mag switch on the starter. There's some new products coming out in the market now that have smart IMSs that will prevent engaging a starter into a running ring gear. It prevents, cranking when the batteries are too low. Just a lot of things. And again, too, when you look at warranty, if you spec overcrank protection, some different things like that, you can automatically get a longer warranty by speccing the right starter. The last thing we're going to look at is different alternators. There's brush design, there's brushless designs. Is it the right amperage total? Does it have remote sense? Remote sense can do wonders, especially in wintertime, that if you do have cables that you're not getting the right voltage back to the batteries to get them properly charged. Remote sense can help address that and tailor the voltage to make sure you get as much into those batteries as you can. And the other thing too is with a lot of the new alternators right now is make sure you get with your supplier is there's more than one alternator that will fit or may meet the amperage requirements. Depending upon your gearing, everything else, that you can put an alternator into a quote unquote sweet spot that's going to be a lot more efficient and do a better job of charging those batteries. And again, too, is depending upon which you choose for your application, what that warranty is going to do. What else can you do for keeping your equipment ready? I'm going to turn it back over to DJ now and let him take over.
All right. Thank you, Larry. Yeah, quite a few other things we can do as well. One of the main things would be keeping your batteries topped off and taking advantage of opportunity charging. Picture here on this slide is a standalone battery charger. So if your truck's in the shop getting some work done, going through some preventative maintenance, possibly sitting for a long weekend, going out in the yard, take advantage of that time and recharge your batteries. You wouldn't want to start a long road trip without checking your engine's oil and filling your gas tank all the way up. You don't want your truck to leave with your electrical system not completely full as well. Another way to keep the batteries topped off and recharge them and make sure they're cycling less, which will only extend their lifetime, is shore power. A lot of people don't necessarily take advantage of shore power, but a lot of people do have the infrastructure available. You pull into the garage, there's outlets everywhere. A lot more fleets are electrifying, whether they're moving to just adding more electronics or adding 4 additional batteries for battery-powered HVAC or EPUs, and really trying to electrify their hoteling. So now you have a bunch of batteries. You need to add ways to charge. You don't want to just always rely on your alternator. So using shore power is a way to do that. Again, lots of truck stops, lots of terminals, lots of places where this is an opportunity to charge. Here we'll discuss inverters a little bit, how to spec the proper inverter, and how to even possibly use that to keep your batteries topped off. One of the main things when deciding what to use on an inverter is making sure it's a correct wattage. Different fleets have different equipment, have different requirements, and even different drivers do. Some drivers need a CPAP machine. Other drivers have some lighter electronics, TVs, laptops. And other guys are using, pretty high wattage microwaves and cooking devices. So depending on what kind of equipment your drivers and your fleets are using, make sure and spec the correct size inverter for that application. There's also, different efficiencies, whether you're looking at modified sine wave or pure sine wave. Again, depends on what kind of equipment you're using to see which one's necessary. But all these things do affect your batteries. The inverter's taking that stored DC power in your batteries, converting it to AC alternating current. And there's different efficiencies out there. So you want to make sure you're choosing an inverter and looking at that spec when you choose. Lvd, low voltage shutdown, is probably the most important. There's a lot of inexpensive inverters out there in the market that simply don't have a low voltage disconnect. They'll run your AC products and electronics until those batteries are dead. You're going to wake up in the morning, truck's not going to start. Nobody's happy with paying for a jump start or the inconvenience of that or a late load. You want to make sure you have an inverter that not only has an LVD, but has one that's set to the proper set point to make sure that you're using less of your batteries, cycling your battery less, and it's turning itself off and turning off your different hotel loads before you bring your batteries down too low. Then again, driver training. Obviously, anytime you're speccing something like this, training your drivers properly on how your particular product works is important. Solar here. This one here is a temporary use panel. To me, it just makes sense that every single truck should have one of these, or at least every garage, every dealer should have one available for the truck. Your truck's going to sit for any extended period of time, whether it's done with maintenance and going to sit in the yard, sitting for a weekend, or anytime it's out in the sun. There's no reason not to at least offset the parasitic draw of all the electronics on your trucks these days. And this isn't just sleeper cabs. Even a day cab with all the different devices that are now in a class 8 truck or even a class 7 truck, all kinds of parasitic draws that we don't realize. That we turn our trucks off and we leave, there's still things that are drawing our batteries down. And especially if they're going to sit for a few hours or even a few days, there's a chance you get back to that truck and it's not going to start. So these temporary use panels are available in a few different wattages, but nice and easy, plug into your 12-volt port, the old cigarette-style lighters. So it's nice and easy, and you just park it in a way that it'll get the most sunlight and counteract a lot of that parasitic draw. It'll just keep your batteries topped off and extend the life of your batteries. Also, permanent installation. There's a ton of fleets that are doing this already today, and in my opinion, we're not that far away of a time when every single class 7 and 8 truck are going to have a solar panel. It just makes sense. I mean, if you look at even 5-10 years ago to now, the amount of electronics and the amount of different both DC powered and AC powered items that we're running on these trucks, all that stuff uses energy and draws your batteries down. Why not only with can you counteract that and offset the parasitic draw, but if you use a quality panel and a large enough size panel, you can actually put some charge back into your batteries, especially if you're using an electric APU. You think about it, you have 8 batteries on this truck to run a battery-powered HVAC system and all of your hotel loads with microwaves and everything in here. Why not take advantage of that free energy? Greatly reduce the amount of auto starts you have, or possibly even eliminate the amount of auto starts you have. Extend the hoteling time for your drivers. This takes a lot less stress off your whole electrical system. And in turn, that's less start, less wear and tear on your engine, less preventative maintenance, less fuel. The savings really is there. It just makes all the sense. Permanent installation on the trailer. Again, same thing, just different location. Whether Larry said it a few different times, whether it's the tractor, the reefer, the liftgate, the trailer, all these different areas have batteries, have electronics, but it's the same principle. Think about the real estate available on the top of the trailer compared to the top of the tractor, and especially compared to the dash. And there's just a ton of room up there to really put a lot of panels, save yourself a ton of maintenance and a ton of maintenance work and replacement on your batteries. Now we're on to our next poll question. Which of the following is not one of the benefits a fleet could see from using solar? So which one is not a benefit? Reduced idle time, improved fuel economy, improved electrical system component life, the last one, improved tire life. Again, please click the correct circle right here on that slide and hit submit. Which of the following is not one of the benefits you could see from using solar? You guys have a few seconds here to choose the correct answer. And pretty much everybody got this one correct. And the one that is not is improved tire life. Fortunately, solar can't do that. Now when it's warmer, I guess the PSI tends to go up a little bit, but solar does not directly do that. Yeah, so you're all set. You follow all the different testing that Larry, 3 different steps, then also incorporate some of the other improvements and different specing different components. Follow all these instructions, your vehicle will be ready for winter. We hear from fleets not just located in Canada and the upper Midwest. We hear from fleets all over the country. When the weather turns, they generally do have more problems. So hopefully this was beneficial, and I hope you guys have a little bit of a less stressful fall and winter. Now we'll move on to the question and answer portion. The tab right at the bottom where you can answer or click in any questions here, and we'll get to as many as we can and read them and try to answer them for you guys here today.
We did have one come in with all the add-ons to today's trucks. How do you find the right CCA rating? Very good question, and that's a very hard question to answer at times. There is a couple of documents that were attached for the material today that covers TMC's battery selection, and there's a lot of things you got to look at on that. Is, you know, first you got to look at your engine requirements. What does it take bare minimum to crank that engine? Then you just want to look at the CCAs and look at the reserve capacity. The biggest thing I'll ever tell anybody is stay away from high CCA batteries. Unless you have a fleet of bulldozers that the only thing they ever do is crank, that is not the solution for you. So typically when you talk about a flooded cell battery, we have a tendency to recommend something in the 700 to 750 CCA with 180, 190 minutes reserve capacity. You do have to be careful. There are some batteries out there that are a little creative in their marketing, that they will try to tell you that they have 1,000 CCAs and 200 minutes reserve. Now, if you're talking AGM, those numbers are achievable. But in talking flooded cell, I get all kinds of warning bells going off because there's just no way to get a battery with those kind of specs that's going to live. They try to cram so much lead in it that it throws the active material to acid ratio off, and that battery's never going to live. So if anyone has questions they'd like us to go into more detail on, feel free to send a comment, email, whatever, and we'll reach out to you directly. So some of those are a little hard to answer on here, again, for all the different applications and fleets we have.
Yep, we have another question here, Larry, regarding shore power and how that relates to battery charging. So there are different options. There is shore power only. So in this application, you would just, plug your truck into shore power when it's available, and it would simply just be passing that AC power through to run your hotel loads. So if you're in a situation where you always have AC power available, you may not really need an inverter to run off your batteries. You can always just plug in and use the utility power. But a lot of trucks out there, don't always have this option. So if there's going to be times where there is no shore power available, that's when you want to make sure and spec an inverter. And if there are times where you can plug in, then maybe an inverter charger is an option. And that's a combination unit. The way that works is you plug into shore power, it'll pass through that AC power to your hotel loads, and any leftover amperage that's in there, it'll actually use that to recharge your batteries. So if you're just watching TV or everything's off and you're sleeping at night, we can throw 80 amps of charge back into your batteries and have them completely topped off by the middle of, or by the time you wake up and ready to get on the road again. A lot of times people don't realize you can get an inverter charger in one unit, a kind of combination unit. We do see fleets out there that have an inverter with a separate battery charger or a battery charger that's only used at the shop, and it's not on the truck. There's all kinds of different options.
One thing I do want to add today, I don't see any more questions coming in, so I do want to at least say, make sure that, we're going to wrap up here soon. And before you drop off, please make sure you stay around for the survey. But one thing I do want to stress that no matter what, as we go into winter, if you do nothing else, at least make sure you start the trucks and make sure the batteries are charged or hook them up to a charger or whatever. And if you're going to park them, again, if you do nothing else, pull the ground cables. That, again, DJ and I have both said many times, there is tons of parasitics on today's trucks. And they may not be a huge load, but if COVID's, created all kinds of new headaches for operation in fleets. But if you're going to park a truck, I don't care, even if it's only half an amp, if you leave that truck parked long enough, half an amp is still going to kill you. It doesn't matter if you get shot with a BB gun or a cannon. If you die, you die. So very minimum, pull the ground cables if you're going to park equipment for any extended periods of time. Yep, had another question pop in. Not sure I understand the question 100%. What's a good handheld? I'm assuming maybe an amp clamp. There's many different ones. If you want, the gentleman that put in that question, send us a message and we'll reach out to you directly, because I'm not 100% sure. Plus, try not to talk anything too specific on these. Our job is to educate and help fleets, but not be overzealous salespeople on these. So yeah, feel free to send us a direct message on that. And if the question was reverting to checking parasitic loads, I do urge everybody, if you look at our library on YouTube or on our website, we have done some webinars and some videos just on checking parasitics that you may find very handy for doing some of these checks.
All right. I guess that is it. Thank you, everyone, for your time. Thank you for participating and joining us today. If you have any questions after, obviously you know how to get hold of Larry and I, both by phone and email. And again, please hang on for the survey. Thank you very much.
Thanks, everyone.